Okay, we'll create the following 3D model using SolidWorks. Basically, what we have right here is this shape. Bear with me. Extruded along this direction. That is pretty much it. We have some different holes along the part, and these two lines either means that there is a corner right here, or there is a rounded corner right here, but we are going to check that information within the views of the engineering draw. First, we're going to create it, and then I'm going to explain some different aspects about the engineering drawing, because I think that it's important to mention. But if you're learning just SolidWorks, please stay for the explanation, and then at the end of the video we will check the engineering drawing information. All right, so we're going to click on the arrow, file, new. This is a part, so part, okay. We're going to click on sketch, sketch once again. We're going to select the front plane, and basically what I like to do is to create the sketch taking into consideration just the proportions, right? Because what SolidWorks does is that, and we will see that later, when you, for example, create two lines, I don't know, this one and then this one, of course, if I change the value of this dimension to something, I don't know, really big, for example 5,000, it is going to keep the proportions. All right, so at this moment this little line, it's not 5,000 or something like that millimeters. But if I change this to 5,000, enter, SolidWorks creates like an equivalence, and then this is going to be huge as well. All right, so that is what we're going to take into consideration for us to create the sketch. Just take into account the proportions. That is pretty much it. So we're going to click on the straight slot option. We're going to create one, taking into consideration that this has to be horizontal. Right there we have it. Then I'm going to create a center line. Escape, and another center line right here. Why is that? Because we have on the engineering draw that we will check later, that every quarter of the part is exactly the same as the other. It is just mirrored, right? So we will take that like property for us to take advantage of the time and be as fast as we can creating this 3D model. So right here we have two circles that I was creating while I was talking, and we just have to select those, click on mirror entities, and then select the point of mirroring. As you can see right here, then we just have to select 4 of those. Then click on, sorry. Okay, as you can see, I'm aware that this is selected because of the color. This is like a cyan or a light blue, and the dark blue is when the line or the part is not selected. All right, mirror entities, mirror about this other line. All right, there we have it. This allows us to create a mirror entity, and when I change the value or the dimensions for this circle, it is going to change as well on this other, and this other, and this other, right? Now we will create the other parts. So right here we have 1, 2, 3 circles. I don't really care about the dimensions just yet. Right here we have another straight slot. Right here we have another one. Okay, no, it's the same one. But right here we have another one. And that is pretty much it. As you can see, a constraint has been created. I don't like that. Right here. Okay, no, my bad. It hasn't been created. This is a correct constraint. Then I'm going to start creating the mirror entities. Okay, right there we have it. Mirror with respect of this line. Sorry. Delete, this line goes right here. And mirror entities with this other. Sorry, once again. Delete with respect of this line. Okay. That is pretty much it. All we have to do now is to define the dimensions. So from here to here, we have 400 millimeters. As you can see, everything was updated. Now, this is 200. Enter. Now this is, let me see, 25. That means 50, talking about the radius. And this is 25, talking about the diameter. Now this is 120. Enter. This is 25 as well. Same as this one. And right here we have 80. Nope. 80 and 95 from here till here. All right, this is 20. Enter, and the position with respect of this line is 50. All right, now what's left is to select the center of this straight slot to the center of the part and say that this has to be coincident. After that, I'm able to define the straight slot, selecting this and this using the shift key. 150. Enter, and the diameter of this straight slot is 40. Okay, as you can see, everything is defined since everything is in color black. If you do not have everything in black, either this is a glitch because that happens. Either it's a glitch because it is not showing the correct color, or it is not defined. Alright, so one way for you to verify that it is correctly defined is to select one part and try to move it. As you can see, I cannot move anything. Everything is perfectly defined and therefore I cannot move anything. Alright, so what's left is to click on features. I'm going to activate the rotation of the space mouse and select extruded boss base. All you have to do right now is to select the parts that are going to be extruded. So right here we have 1, 2, 3. It is basically selecting the closed sketches for you to extrude. It looks good. Let me see the dimension. This is 50 millimeters, so 50 right here, and okay. Okay, everything looks good. What's left is to create the rounded corners, because I can see right here in the engineering draw, and basically all we have to do is to select a fillet. Okay, double click right here, and there should be an option. Nope. Yes, this is the one. Let me see. Nope, this is not the one. No, this is not the one as well. Okay, but this is one that works as well. The thing is that the radius is 5 millimeters. As you can see right here. Then I'm going to select this other and select the same option that we have. Alright, everything looks good. Okay. And this is pretty much it, guys. This is how you can create this 3D model using SolidWorks. Now, regarding the engineering draw, there is some things that I want to mention. First, when you're creating an engineering draw, and this is for the people that wants to stay in the video, you have to take into consideration some different aspects regarding the normativity that you are using. For example, these two graphical representations either means ISO A or ISO E. Right? You can use either this one or this one, but you cannot use both in the same engineering draw because that is a mistake. All right? Why is that? Because if you Google ISO E, ISO A engineering drawing, and you click on Google Images, you will see that this depends on the views that are created or that are shown within the engineering draw. For example, if right here we have the left view, either this is the front view or this is the left view, but you will understand it better in Google. You just have to see a picture and that's pretty much it. But you cannot place both of the notations within the same engineering draw. Now, this is Spanish for exercise 5, aluminum, steel copper. Please take into consideration that there is a box in which you place your name, you place the material, you place some information needed, for example the tolerances if it is engineering draw for manufacture, and everything else, for example the name, the number of the engineering draw if there's more than one, for you to not do this. Okay, do not do this. Now, regarding the dimensions, please use or tell the reader the unit system that you are using. Alright, why is that? Because the reader is going to take that in consideration, of course. If he does not know if it's working in inches, feet, millimeters, meters, whatever, he can do what I did. I can assume that these are millimeters. This is a rule. If you don't find that information within the engineering draw, you can assume that these are millimeters. Right? Now, the third thing, organize the dimensions outside of the part. This is a non-written rule. This is not mandatory, but looking at dimensions within the engineering draw, sorry, this one, not this one, this one, and that is pretty much it. It is not well seen, you know. It is like an error, but it is like an error, but it's not an error. So please do not do this. You can place this dimension right here, or this dimension right here. You have plenty of space around the part for you to place the dimensions. Now, do not put crossing dimensions. This is a mistake, because you can confuse the reader. Of course, this is pretty simple to see right here, but if you have a lot of different dimensions and you crossed the lines, then the reader is going to be confused. Now, for your knowledge, this is just a nomenclature that means 4 times a diameter of 20 through all. Okay, this is Spanish for through all. This means that 1, 2, 3, and 4. The 4 of the circles are, every single one of them is 20 millimeters, talking about the diameter. All right, now, this is a section view, as you can see right here. This is not necessary, guys. He's only placing the radius of the corner, the fillet in this case, and he can do that using the bottom view or the top view, right? As well as this other dimension, which is the width of the part, right? Please take these personal advices into consideration for when you want to create an engineering draw as well. Keep in mind the proportions. This is too small and this is too big for the engineering draw. He could have used a different size and place it, for example, right here, and right here could be the isometric view. That gives you like a professional view to your drawings. All right, that is pretty much it, guys. That is what I wanted to mention about the engineering drawing. And that's it. This is how you can create this 3D model using SolidWorks.